Yara Universal is the leading expert in the design and fabrication of critical environment applications. We offer a complete range of equipment, furnishing and supplies for cleanrooms and laboratories. Following are the rigorous standards to which Yara Universal adheres. Before global cleanroom classifications and standards were adopted by the International Standards Organization (LS-LIN), the U.S. General Surgical Administration's standards known as FSR were applied virtually worldwide. However, as the need for international standards grew, the LS-LIN established a technical committee and several working groups to delineate its own set of standards. A critical factor in cleanroom design is controlling air change per hourage, also known as the air change rate, or ACR. This refers to the number of times each or that filtered outside air replaces the existing volume in a building or chamber. In a normal home, an air conditioner changes room air 0.5 to 2 times per hour. In a cleanroom, depending on classification and usage, air change occurs anywhere from 10 to more than 600 times an hour. ACR is a prime variable in determining ES-LIN and federal cleanliness standards. To meet optimal standards, ACR must be painstakingly measured and controlled, and there is some controversy. Laying an appendix to its ES-LIN 14644 cleanliness standard, the International Standards Organization aids applications for microelectronic facilities only. in classes 6 to 8, Federal Standards 1000, 1,000 and 10,000. The appendix contained no ACR standards for pharmaceutical, healthcare or biotech applications which may require higher ACR regulations. Occurring oil current research case studies and experiments using an ACR range rather than one set standard is a better critically to cleanliness classification. This is true because the optimal ACR varies from cleanroom to cleanroom, depending on factors such as internal equipment, staffing and operational purpose. The wording depends on the level of outside contaminants trying to enter the facility versus the level of contaminants being generated on the inside. The breadth of these ranges reflects how dramatically people and processes affect cleanliness. Low-end figures within each contamination class generally indicate air velocity and air change requirements for an as-built or addressed facility where no people are present and no contamination is underway. When there are people and processes producing contaminants, more air changes are required to maintain optimal cleanliness standards. For instance, some manufacturers insist on as many as 7 air changes per hour to meet Class 2 standards. Determining the appropriate number of air changes for a particular application requires careful evaluation of factors such as the number of personnel, effectiveness of guarding protocol, frequency of access, and cleanliness of process equipment. Ryan J. Honey, in his paper Energy Efficient Low Operating Cost Cleanroom Air Low Design, presented at STEC 2003, recommended the following ranges based on FSR 09 classifications. Federal and low airflow velocity standards. In addition to ACR and ceiling coverage, the third factor integral to maintaining cleanliness is fan-generated airspeed. Again, higher airflow velocity results in a cleaner cleanroom. The term ventilation efficiency refers to the speed of filtered air passing through the cleanroom in addition to the number of air changes per hour or ACR. An earlier chart showed a range of recommended air change rates as CRS for different classes of cleanrooms. Ranges are given because as-built and at-rest facilities require a smaller ACR than an operational cleanroom, where both people and equipment are actively engaged. Non-operational cleanrooms are found in the lower range, operational cleanrooms higher. Combining all three factors, ACR, ceiling coverage and airflow velocity, results in the following table.